So we are now in section 6.5, and I want to do example 3. Example 3 is at the bottom. You have looked and heard a lot and practiced a lot with graphing tangent and cotangent, the sine and cosine, and now we're at secant and cosecant. I know you've already seen 2 videos on this. I wanted to step in and do this last problem with you and show you some things I'll be looking for on the test. So as you see, they're asking us to graph y equals 2 cosecant x minus 1. It says use the graph to determine domain and range, and I'm going to focus here on the graphing first. And so as you notice here, I just rewrote it. I'm going to scoot all of this down. All I did was rewrite this for what we are trying to graph. We've got a whole lot of writing going on here. Where are we? There we go. And so with this graph, I want to hope that's not on the screen and messing it all up. There we go. And so looking here, we are going to graph y equals 2 times cosecant of x minus 1. I do a combination of transformations and the 5 important numbers. I'm looking for the 5 key numbers, but I want to show you what I'll be looking for specifically on the test. So the first thing I would do is ask what type and what direction. And when I look at this, with it being a positive 2, it's going to be normal, whatever that is. It's not going to start and go upside down. And it's going to be a cosecant. And so in the videos that you've seen and all that you've been looking at, cosecant relates to sine. So that's what I like to do first, is to go ahead and get my brain wrapped around, trying to make sure y'all can see this, that what we're about to look at is going to revolve around a sine graph. But it's not going to be the sine graph, and then what is she going to grade? What is she looking for? So I'll go ahead and just start with a regular sine graph. We've got a pi over 2 or 3 pi over 2. And regular sine goes up, then down, then at its lowest point, and back up to 0. And it can repeat that going the other direction. So there's our regular sine graph. And if we were just doing regular sine and regular cosecant, then from right here, at our high points, we would do our parabola, and at our low points, we would do our parabola. But we've got a little bit more going on, and so let's set the foundation before we start doing our parabolas. So the first thing I like to ask myself is what type and what direction. It is going to be cosecant. It is based off of sine, and it's normal. It's not that this is going down first, it's going up first. And then I will ask you on the test, what is the amplitude? And the amplitude is coming from that number right there. We're supposed to take the absolute value of it, and we get that it is 2. So no matter what is about to happen, noticing we have a 0 in the original graph, and that meant our amplitude was 1 above and 1 below. So wherever our 0 horizontal is, we're going to go 2 above and 2 below. But it may not actually end up being 2 and 2, especially if we end up shifting up or down. But just to get my brain oriented, I see that my amplitude from wherever I am is going to go up 2 and down 2. Then I like to look and see what is period. Period is 2 pi divided by omega. This is where it starts to get a little crazy, because sine and cosine had the period of 2 pi. Oh, and then we did tangent, cotangent for a little bit. They had a period of pi. And now we're back to secant, cosecant, and I've got to keep these straight in my brain on which one I'm working on. And so I look for, you can't see that, I look for what is my number inside with the x. Well, it's a 1. And so what I'm doing is kind of redundant, but I want to walk through it anyway. That I would put a 1 there, and, well, it's just a regular cycle. This one is going to repeat itself every 2 pi. Well, that's pretty cool, because looking down here, I started, went up, went down, and back to where I started. So that's going to be my format. But I've also asked you to talk about subintervals, to take your period and divide it into 4 parts. To me, this is critical. It is very important to help wrap your brain around what's going on this graph. And when I do take my period, divide it by 4, I get a 1/2 pi. So I've got something important something very key going on every half pi. And so if you look here, it was in the original. I had a zero, an x-intercept going on at this point. Oh, and then there it is. My pi over 2 is going to be my very important part. And so I got something going on at pi over 2, something going on at pi, another half pi, and another half pi. So 1 pi over 2, this is 2 pi over 2, this otherwise known as pi. This is 3 pi over 2, and now I have 4 pi's over 2, otherwise known as 2 pi. So this is shaping up very well. Nothing scary, nothing weird going on here, just very straightforward. But I got to keep in mind that I'm not graphing sine. I'm graphing cosecant. It's normal. It's going to be above 2, below 2, wherever my 0 is. I've got a period. It's repeating every 2 pi, and my subintervals that are at every half pi. And so I wanted to go ahead and introduce that in the next section we're going to talk about phase shift. This one does not have a phase shift. I'm not going to explain it. Might as well. It's when we're going to be shifting on the horizontal, going left or going right. We don't have one. And where we're going to find it is going to be inside of, there's going to be something inside of, like a plus something or a minus something with the x. We don't have it on this one, but I wrote it down just to start introducing it. The vertical shift, we have one. And so in the vertical shift, it's going to be whatever's way out there. Pretty much everything we've done so far has just been 0. We've had a couple thrown in, but this vertical shift, it is what it is, and I need to see both it is what it is. Minus means we are going down. How many spaces are we going down? 1. So for vertical shift, I need you to write. Our whole graph is going to go which way? Down. How many? 1. And so now back to our graph. Everything that we thought we knew, we still know, but it's going to shift on us. So we are not going to go all the way up to 2. Everything's getting shifted down 1. So our highest point on this graph is going to be a 1. Our lowest point is not going to be -2 because everything is getting shifted down 1. So we now have our highest point and our lowest point. And one other thing I like to do is my x-axis, my 0, where everything's revolving around, is also getting shifted down. And I usually like to go ahead and show that my new horizontal line has now been shifted down 1, and now I can start to wrap my brain around. Where I used to go through the axis at 0 for the regular, I'm going to go ahead and fill these in. For my new, for where I am now, my new sign is going to be going down here at 0. The highest point is going to be up at 2. I'll come back down here at 0, my lowest point here, and then back to 0 here. That's not really 0. It's my old 0, which got shifted down, which is now at -1. But it really helps my brain to see that's the new stuff going on based on the new amplitude, the period that's the same, and the vertical shift. To carry this on, let's see, I had pi, that would be pi over 2. So my lowest would be here. I would be back up to 0 here. And so I don't know how you want to take care of this, but I don't have to see the sine graph, because that's not what we're graphing. But we're using it to graph cosecant. So now we're going to finally get to graph where we started. We want to graph 2 cosecant x minus 1. And then we're going to have to do our 5 key points, and we're going to have to make sure we go 2 complete cycles, and that will get us full credit on the test. So while I'm here, I've only gone back to negative pi over 2 and negative pi. Let me go on back to negative 3 pi over 2, and let me go on back to negative 2 pi, and finish out that I'll be going my highest point where, nope, that is wrong. This one is wrong. I'm back at my 0. My lowest point is supposed to be 2 away. My lowest point is supposed to be 2 away. But look what I've done. I've gone 1, 2, 3. That is not correct. My highest point is only supposed to have an amplitude of 2 away from where I was. So it only goes up to the 1. That's why I like to keep talking to myself while I'm doing all of this here stuff. So here, lowest, 0 at 3 pi over 2. I got to get back up here to my highest point, and then I got to get back down here to my lowest point. So the pencil is my correct sign. Now I want to impose cosecant. So I'm going to pull out green. In cosecant, everywhere there was a 0, I have to consider that it is an asymptote. So what am I grading on the test? I'll be grading asymptotes. Make sure you draw asymptotes. What else am I grading? The parabolas of the actual cosecant. There's one. Here's another. And I think you get the idea. So what's in green is what I'll be grading for your graph. But I will ask you what are 5 key points. And I would stick with this original side. You can give me negatives. I'll be ready for whatever you hand to me. But I would stick with this side over here. And I'm going to go right here at this first that used to be my 0. It's not 0 anymore. But we go down, 0 and down 1. Here, we're at pi over 2, and we ended up going up to 1. Here, we are at pi, and we're back down at negative 1. Here, we're at 3 pi over 2, and we're down at, whoa, where are we now? Look at that, we're down at negative 3. Oops. And then when I get back up here, I'm now at 2 pi, and I'm back at that negative 1. So for a full credit on the test, I need you to show me what I have in green for your graph. I need to see the asymptotes and the actual parabolas. You can have a whole lot of other junk going on, but I do need to see those parabolas in 2 complete periods. I have an up-down and an up-down, 2 complete periods. And now down here, I've shown 5 points that are on, that are considered part of, well, and then we can argue with that other one because it's going to be a, well, it's not going to exist at the negative 1. Because that's not going to be a point. That's the point for the sine graph. So those aren't going to work. So what I've got to have is something going on in between. So I'm going to go lazy here. I'm going to go split the difference here and here. And when I split the difference there, I get pi over 4 and 3 pi over 4. Because these points, those aren't my 0. Those are undefined. So I only have 2 points. This will help me to get a couple of more. I could use these 2 over here. I could come over here and go ahead and look at that's 3 pi over 4, 4 pi over 4. I can go here and I can get my 5 pi over 4. But I got to find out what goes with them. And so I'll need to make a chart. And my brain is also thinking, how do we check these? So before I go any further, I want to go ahead and just check. Let's see if everything I've done is working. So what I want to do is I want to take this point right here. I want to take this point and I want to go up here and I'm going to draw a chart for my x and my y. And I'm going to put 3 pi over 2 as an x to try, but I already know that when I get through calculating, I want negative 3. Because I just did a whole lot of stuff. I messed up on one part. I'm not sure about another part maybe. Anyway, we want to have some way to check through the back door. So while I'm looking here and looking here and looking here, oh, you can't see this, but right here I'm going to check to see if when I plug in my 3 pi over 2, I actually get a negative 3. So I'm going up here. I realize I still need some more points, but I'm going back up here and I want to check. So looking here at my formula, my y is worth 2 times the cosecant of, in this case, it's the cosecant of 3 pi over 2. After I calculate that, I'm going to subtract 1. So I'll grab my calculator. I'm going to grab my calculator. I'm going to go decimal version. 3 pi over 2 is 270. So when I grab my calculator, cosecant's not on my calculator. So I'm going to need to do not cosecant, but 1 over sine of the 270. So 1 over sine of the 270, let's do sine. Oh, we can just go ahead and do it this way. Oh my gosh, slow down. 1 divided sine of 270, close parens, and hit equals. Oh, it's a negative 1. Okay, this is a negative 1. And so 2 times negative 1 is negative 2 minus a 1, and lo and behold, smiley face, we did it. What we thought was supposed to work out, where we thought we were supposed to land according to amplitude and vertical shifting, we did. We are there. The world is great. What we've got going on is good. We just need to fill in with a few more points. Again, I'll ask you for 2 complete cycles, and I'll ask you for 5 points. The only thing, our 5 key points don't work out so pretty because they're undefined. So I'm going to go right here and plug in my pi over 4. I've also noticed that where about a 3 pi over 4 would be. So these are over here. They're in the 1 to 2-ish area. Who knows what's going to happen, but somewhere in that area, definitely positive. And then while I'm here, I'll go ahead and do 5 pi over 4, which is going to be negative 3-ish or 4-ish. And so 5 pi over 4. And so looking here at our pi over 4 is our 45-degree angle. So here we go. I'm going to plug in 1 divided by, not cosecant, but sine of 45, and I'm going to hit equals. I'm going to multiply it by 2, I'm going to hit equals, and I'm going to subtract 1 and hit equals. So about-ish, right here-ish, we have 1.83. So about 1.83. So what you need to know is on the test, sometimes I'll officially ask you to write down these 5 coordinates, and other times I'll ask you just to go circle them. So if I was on the test, here's a coordinate, and here would be a beautiful coordinate. I probably won't ask for exact on this, especially when we start getting into like the tangents and the cotangents and the secants and the cosecants. We can get away with it more and we can do it more, I believe, for the sines and the cosines. However, I'm not going to work this out any differently. I don't want to do any multiplying and reciprocals. I'm just going to leave it right here. But I need to ask, at pi over 4, does this look about 1.83-ish? And it does. And now I'm going to do even more lazy. If I think I've done that right, because of symmetry, that one ought to be 1.83 also. Whew, we got 4 points, we got 1 more to go, so let's do this 5 pi over 4. On the 5 pi over 4, that has gone around 180 degrees, and now we've gone past it 45 more. So this one is a 225, and we can either punch it in radians or we can punch it in degrees. I'm going to go ahead and punch it in as degrees, and here we are again. Hit clear a bunch of times. I can't punch in cosecant, but I can do 1 divided by sine of 225, hitting equals. I need that one times a 2, hit an equals, and then I need to subtract a 1, hit an equals. We're getting about a negative 3.8. And so looking down here at about-ish, this point-ish, at 5 pi over 4, if this is negative 3 and this is negative 4, are we about at negative 3.8? And we are. So a lot of stuff crammed into one problem, trying to talk you through some stuff that we've seen, what I'm expecting on the test, and even foreshadowing some information to come. Here concludes example 3 on page 426 and 427 in section 6.5.